Hey, good afternoon, everyone, and welcome to my session, and welcome here in the Azure Day as well. I hope you already had a good morning so far, and I hope you enjoyed the session up till now. And I know it's probably lunchtime for a lot of you, so if you're watching this right now, thank you for being in my session, where I'm going to try to talk about one of the probably hardest topics around Azure, but also some misconceptions there. And that's where Azure is providing you 100% high availability or not. Where first of all, we obviously need to thank several of our sponsors. And without those, it wouldn't be possible to even organize an event like this one. And this is my first time actually presenting at this conference. So thanks to the organizers as well for having me. And I'm a bit down that it's not in person because I personally enjoy traveling a lot. And specifically, if there's any trip to Italy, then I'm probably one of the first ones getting on a plane and getting over. But unfortunately, we're not in that way right now. So I'm going to try to keep it entertaining enough during the next 45, 50 minutes and talking about the exciting Azure world. A little bit about myself. I've been working with Microsoft technology for more than 20 years. Initially started with traditional data center technology, but about 6-7 years ago, out of my background on Exchange Server and everything around deploying mail infrastructure with data center, firewall, storage, everything, quickly jumped to Office 365, and that was my way into the Azure platform. And quite fast, actually, I decided to stop working with traditional data centers and moving into Azure all the way. In meantime, I'm FTE within Microsoft Belgium, but working all over EMEA region, providing Azure readiness workshops to partners and customers. So you got my contact details here. Feel free to reach out online. LinkedIn, Twitter would be my preference there, or send me an email, petender@microsoft.com. So a quick walkthrough what I'm going to try to help you with. And I know the topic is a little bit too short for obviously drilling down on all the details in the next 45 minutes, but nevertheless, I'm going to try to jump in the different parts of the platform. First of all, starting with the high level public cloud landscape, like what's the idea, the capabilities we have around high availability when moving to a public cloud scenario, and talking about high availability SLAs. What does it really mean when somebody's asking for 2 nines, 3 nines, 4 nines, and what might be the impact for our business? And then walking through different parts in the Azure platform. So depending a little bit how you want to run your platform capabilities, starting with some networking high availability features we offer in the platform, walking you through some high availability concepts when you run virtual machine infrastructure as a service, and then slightly moving over to platform services, running web apps, running functions, and talking a little bit about containers as the closing part. We do have Q&A here all the way at the end, so feel free to send in your questions, and my moderator on the other side of the line will keep those questions for me, and we have about 10 minutes reserved for Q&A all the way at the end. So then let's jump in. Now, the first question is moving to a public cloud environment. What does it mean? Now, for a long time, you were probably running, and maybe still today, you were running your on-prem data centers, which means you need to fix everything. You need to take care of the monitoring, the deployment, the high availability. What if something goes wrong? What about disaster recovery? So there's a lot of admin overhead. Besides the complexity, the frustrations, the nightmares, if you want. I remember in my early years in an Azure data center that, in an on-prem data center, that most of my weekends was the typical maintenance weekends at our customers, or sometimes even used for extended disaster recovery. And then slightly moving away from the traditional data center approach is moving to Azure, where you're still going to run your virtual machines in a lot similar, identical way than what you're running on-prem. but it's also taking away some of the pain points, because you don't need to manage the actual infrastructure anymore. You don't need to focus on the physical parts of the platform. It's all running virtual, so it makes your life a little bit easier. You can integrate with the Azure built-in capabilities. And at some point in time, you're going to step away from infrastructure as a service and maybe moving to platform as a service, which means you're still going to run the same workloads like web apps, database, service, but you're not managing the virtual machines anymore. And as you can see, just as an illustration, it's taking away the overhead, it's taking away the management complexity, and even the architectural complexity, where you can really focus on the platform workload capabilities. And then last, you might also move to a serverless concept, where you're not having virtual machines anymore. You're not even really managing the platform anymore, but you're running serverless compute, which in Azure means functions, logic apps. So really using software as a service almost, where you're not managing anything besides really focusing on the core capability of your workload. So 4 different options, 3 different options once you start moving to cloud. And you could also come up with the fact that, so it means that once I'm moving to serverless, based on the 4 diagrams here, that I don't need to worry about anything anymore. But that's not really the case. So quite important, no matter what architecture you're using, whether it's running virtual machines on Azure, platform services on Azure, or moving to serverless, you always need to consider high availability as part of your architecture. And next to that, it's really an art, where what I'm trying to say there is that it could still become challenging, sometimes even really challenging to make it 100% high available. But on the other side, it should also make your life a lot easier, because a lot of the high availability is obviously already baked in the platform. And that's what I'm mainly going to try to walk you through in this session. So that was the high-level introduction. So now we know that Azure is not giving you just one single SLA, not giving you one single way to run your application workloads, but you can really choose and you can mix them. So you can deploy virtual machines together with PaaS services, and in between using serverless as well. So the next part is, what do we mean by SLAs and high availability? So technically, as an IT admin, a developer, security officer, you're most probably worried about what is the uptime once I start moving my workloads to the cloud. And I'm going to walk you through a couple of different scenarios later on. But what it means is that Azure by itself, just like any other cloud, public cloud platform, as well as your on-prem data center, is not coming with one single SLA. So throughout the next couple of slides, you're going to find out that different Azure services are coming with different SLAs, and sometimes even different SLAs for each and every service type you deploy. Now, overall, when in the industry we're talking about SLAs, it typically is expressed in numbers of nines. So the ultimate one would be the 4 or 5 nines, as we call it, where the 5 nines means the average downtime per month, or the potential downtime, because we're not going to force downtime, obviously, whenever we don't need it, is roughly 30 seconds. Where the 4 nines, it's one that you typically see on a lot of Azure services, is around 4 or 5 minutes potential downtime per month. And by the way, in Azure, all SLAs are always expressed on a monthly basis. And then the in-between average one is 99.95 and 99.9. So easy said, any service in Azure is going to give you anything between 45 minutes potential downtime per month, all the way down to only 25 seconds. And it's up to you to really integrate it, to decide it on in your architecture. And that's what I'm going to try to help you with. So it starts with the Azure high availability itself. Now, when we talk about Azure, it's Azure regions. So physical locations, different places all over the world, where for now we have around 60 active Azure regions. Now, why do I say around 60? Because it's partly changing fast, and there are more probably a couple of regions that they already announced, where the recent ones, I think, were Italy and Spain and Poland. And The newer ones within Europe, the last couple of months were Switzerland and Norway. But as you can see, it's pretty well represented all over the world, which means that as an organization, as a customer, you could actually really use that high availability already on an Azure regional perspective. So nothing would block you from deploying your workloads in whatever flavor, virtual machines, PAAS, or serverless, running them in multiple regions, as long as you keep compliance in mind, which means that maybe technically you're allowed to run your workloads in a different region, but from a data compliance perspective, you might not be allowed to run it outside of Europe, for example. But you can definitely use it. So once you have this high-level Azure regional concept, and again, since we're talking about high availability, it is quite important to get a view on the availability of the region. So Azure tries to help you with a landing page, a dashboard. It's called the Azure Status or Azure Health. And what we do from there is providing a real-time overview with like a 2-minute delay that gets refreshed automatically and walking you through an identification of any potential service that might be down, having impact, or maybe not being down, but not functioning as it should be for the different regions all over the world. And with that, jumping to a first demo where you can connect to status.azure.com. And this is going to provide you a real-time web page. So the loading time is always a little bit having a little of a delay because it's trying to feed you real-time information. So from here, if I scroll down a little bit, it's going to provide me a detailed view for the different Azure regions or the different Azure geographies. And from there, highlighting if anything is having an impact right now on the platform. Now you could go like, yeah, well, this is all fine. It's all green. So it means that everything is up and running. And just quickly checking. And yes, for Europe, it's all green. And most probably for the other regions as well. But next to that, it's actually not always green. And I'm not joking about it, but every now and then there is an issue in the platform. And it's sometimes planned or unplanned maintenance, or just having some impact out of like a regional outage. And we're not even hiding that information. We're literally telling you what's going on. So out of this high-level public dashboard, you can drill down on service health, or from within your Azure subscription, you could directly go to service health yourself. And that's going to zoom in and drill down on the specific issues in the regions that you are using or the ones that you want to get informed about. So for now, we know that nothing's really wrong, but nevertheless, it's still keeping track of any issues we had in the recent time frame. So from here, and this is nice because I cannot really prepare for this. Every now and then there's nothing showing up, or sometimes there is something showing up. So apparently we had an incident with Application Insights, our application monitoring tool in the East US regions, where besides listing up the incident itself, we're also going to provide you the details and any root cause analysis, sharing feedback with you as a customer about what's going on, first of all, and also how we try to mitigate and fix the problem. And obviously, if you are using any service in Azure where everything is running fine, and all of a sudden it's not running as fine as it should be anymore, the first reaction would be check out if there's any issues reflecting on the service health. So that's high level. Easy said, if any region is down or a specific service within a region is down, then step one, check if there's any issues within. The next step is building out your own infrastructure, where typically it would start with the networking layer. So when you're going to build out virtual machines, you need storage, you need networking, but also if you're going to use platform capabilities, you would also use some kind of networking integration. Now, when you look at your traditional architecture for a high available workload, easy said it means that you're going to deploy at least 2 instances. So even in your on-prem world, if you have a web application, you're going to deploy 2 web servers, maybe more, but at least 2. And on top of that, you're going to run the 2 web servers on 2 different hypervisors. So maybe VM server 1, VMware server 2, or Hyper-V. And you're not really mixing Hyper-V with VMware or the other way around, because that's probably giving you more headaches than what's good for the high availability. And it's the same analogy on Azure. So you're going to deploy your workloads. And as you can see in this diagram, we're going to expand it with load balancers. So if I zoom in a little bit, we have virtual machines, but this could technically also be app services like a web app where we're not using VMs anymore, but I'll talk about those later on. Or you could also use it for database backend services. This diagram is using SQL, but it could be MySQL, Postgres, or even using a Cosmos database. Now for the connectivity itself, once we deploy multiple hosts, like multiple web virtual machines or web apps, we're going to add a load balancer in front of it. So back to the SLA, it means that when you deploy your Azure backend applications and you're going to add a load balancer in front of it, out of the platform, you can choose between 2 different flavors. We offer Azure Load Balancer and Application Gateway. Now, again, I don't have a lot of time to drill down on all the details and the differences between each and every service, but Azure Load Balancer is a traditional load balancer, as you probably know it, that allows you to load balance on any TCP/IP port, where Application Gateway is a load balancer as a service, so it's not a virtual machine appliance, and it allows you to load balance web traffic only, so it's HTTP, HTTPS traffic. But next to that, it also comes with web application firewall with redirection rules. So it's a bit more intelligent than using the traditional Azure load balancer. Now coming back to my previous topic about Azure regions, when you deploy an Azure load balancer or application gateway, it's always active in that one single region, which means, and as you can see that in the diagram, it means that if you want to move up to ultimate high availability, you're going to use internal load balancers. You're going to use front-end load balancers, application gateways in case of a web app, and you would automatically move it to different regions as well. So load balancers in one region, load balancers in the other region, and high available virtual machine or application services. But what if you want to load balance across multiple regions? So I'm reusing the same diagram as before, but this time I also want to load balance my Azure region, where easy said, if my user is connecting to the public internet, connecting to region 1, connecting to region 2, it should be a simplified connection method for the user first of all. But next to that, if my prime Azure region is down, then I somehow want to make sure that my user gets redirected to another region where I again have the same high available workload up and running. And that's where Azure offers you 2 additional load balancers, where the 4 nines, so the 25 seconds potential downtime, comes in, and that's Traffic Manager and Azure Front Door. Now, looking at the previous one, we talked about load balancer and application gateway, where this time Traffic Manager and Front Door are following the same logic. Traffic Manager can load balance across multiple Azure regions, no matter what kind of traffic it is, and Front Door is only capable of load balancing across different regions, but only recognizing web traffic, but it also comes with the web application firewall, redirection rules, and some other intelligence. And it's all nice to talk about it, but let me show you in another demo what this technically looks like. Now, to speed it up a little bit, I already deployed my Traffic Manager. And within Traffic Manager, it's connecting to its own namespace up here. Technically, you would use a custom DNS CNAME alias to point to portal.azure.com, which in the back is redirecting to Traffic Manager. But more important is that we define endpoints. Now, what is an endpoint? It can be a little bit of everything. Where the typical ones is an Azure App Service or a fully qualified domain name, which means that it can run in front of an Azure service, but you could also use Azure Traffic Manager to load balance between Azure and your on-prem data center or maybe another public cloud. So I have 3 different endpoints. So let's see if we can actually connect to one of them. So now I'm redirecting to West US, and the reason why is because out of my connection right now, West US is giving me the closest by the fastest response, which means that if I would now stop my West US web app to simulate a failure in that environment, literally stopping it from now, and let's try and open a new connection. It's going to tell me it's down for now, and this is partly because I'm simulating the error. So I'm going to try to speed it up a little bit and opening up a new connection, where this time it's redirecting me to East Asia. So it detects that US is down, and it's going to send me to another region where obviously I have an exact same copy of my workload running. Now that little hiccup in between is partly because the website is static, so your browser is doing some caching as well. And the traffic manager is based on a DNS time to live, which by default is 30 seconds. So that could somehow influence the high availability a little bit as well, where it could take up to 30 seconds before your browser is actually aware about the fact that the endpoint is not there anymore. But that should be manageable. It's about the same for front door. And let me show you how this one works. So I already have one up and running, but what front door is doing is providing load balancing HTTP, HTTPS for, again, different endpoints. So you start with defining, make it a little bit bigger. So you start with defining your internal URL. So I'm connecting to Azure Web Apps, and I'm also pointing to a public DNS namespace. From there, I'm load balancing a backend pool, which in my case is an Azure Web App. And next to that, and that's the intelligence that comes with front door that Traffic Manager is not really giving you. And again, it's specifically for web traffic, HTTP, HTTPS, is custom routing rules where you could come up with a scenario to integrate SSL certificates, web application firewall, and next to that, custom routing. If somebody connects to portal.azure.com, we're going to redirect you to azure.microsoft.com or microsoft.com/Azure, something like that. If somebody comes in connecting to microsoft.com/videos, that we're going to redirect you to videos.microsoft.com, something like that. And that's all part of front door, high availability, load balancing across multiple Azure regions. And quite important, you need to have multiple endpoints, obviously, to make it high available across multiple regions. So that's the networking stack, where the next capability is virtual machines. You said you deploy Azure virtual machines, and you got a couple of different options. The first option is a single virtual machine. So you go to the Azure portal, PowerShell, CLI, Azure template deployment, and you're going to deploy a single VM for like test and dev, maybe demo purposes, and it comes with a 99.9 SLA. If you remember the numbers from one of the first slides, it's roughly 45 minutes potential downtime, which for a lot of virtual machine-based workloads is not good enough. So we're going to move it up to what we call an availability set, and that is where we're going to make sure that you need to deploy 2 instances or more within the same Azure building. And that's going to move up the SLA to 99.95, or ultimately moving to 4 nines in what we call an availability zone. And that's where you're going to deploy 2 instances or more, so 2 identical VM workloads, where now they're going to run high available in the same region, but across multiple physical buildings in an Azure data center. And showing you what this looks like, I cannot really show you where the virtual machines are actually running, besides the fact that they run in a certain region. But when you want to make your virtual machines running on Azure in a high available setup, quite important, you need to define that during the deployment. And what it technically means is, let's say we're going to deploy it in West Europe. You start with VM1, and remember, you need to deploy at least 2 of them, identical ones. We're next in the availability options. You're going to specify a zone, which means one region but multiple buildings, or availability set means high available, 2 virtual machines across different physical nodes in the backend of the data center, but they're still running in the same building. So you would start with availability set, and if that's not good enough for the business requirement SLA, you would move to an availability zone. And technically, even running this across multiple regions, availability sets or zones in one region, availability sets or zones in another region, and on top, the multi-region high availability. That's VMs, where the next part is application services, where app services is a larger terminology for different application capabilities. So you could have logic apps, you could have web apps, you could have Azure Functions, and Event Grid as well. Where Event Grid is not really part of app services anymore because it's moving more to serverless. So depending a bit on the app service you're using, the SLA is going to be different. So keep that in mind as well, that it's not similar to the virtual machines depending how you architect it, but it's really depending on the service itself. And then last, we got containers, or maybe even moving to Kubernetes services, where it depends again a little bit on the service you're using. If you deploy an Azure container instance, like a standalone running container, it's providing you an SLA of 99.9. So again, the potential roughly 45 minutes potential downtime. If you deploy an AKS or Azure Kubernetes service, it's going to move up the SLA to 99.95. Now, although Kubernetes runs as a service, it's technically relying on virtual machines. So everything I talked about in the last couple of minutes around virtual machine high availability is exactly the same for Kubernetes. So what you would do is deploying a Kubernetes cluster as part of an availability zone, meaning we have physical nodes, physical racks in the data center, all in the same region, but still in multiple buildings. So if you deploy a 3-node cluster, it would probably spread out the 3 different nodes across multiple buildings. And under the hood, to actually allow containers in the platform, you need a container registry. Think of it as a library to store your container images. And that's also coming with an SLA, and we're relying on Azure overall storage SLAs there. That's going to bring me to my last demo. So I'm going to show you container instance where my cursor seems to be gone for some weird reason. So I'm going to try this a little bit different. So the starting point in containers is container registry. So that's the landing page, if you want, the location where you're going to store your container images. Now, an image itself is not really doing anything, so we need another service to actually start up the running container image and having a full active workload. So what we can do from here is connecting to a repository where I have a little application running. It's called Simple Commerce, so it's a simplified e-commerce environment. So what we're going to do is creating a new container instance and pointing to my container registry. So you would provide the name, the location where to find the container image. So this is my container registry, the name of my image that I want to use, I'm providing a name, AZ Day, something like this. And as you can see, it's not asking you like, what is the high availability? How do you want to run your containers? Because it's one SLA for the full service. So from here, it's going to create, and since it's containers, it means it's actually not taking too long. So this is going to start up my container instance service, connecting to the container registry and starting up my workload. Now, if I want to make my container standalone container instance more high available, it would again mean similar to virtual machines, similar to app services, that I need to deploy at least 2 instances or more in the same region with a load balancer in front of it, maybe across multiple regions with, again, Traffic Manager or Azure Front Door in front of it. And that's where Kubernetes comes in play. So while this is deploying, I'm going to switch to my Kubernetes environment. And Kubernetes by itself is running on top of virtual machines, but you don't really manage them, you don't really see them. So think of it as a full-blown service, although under the hood, it's relying on Azure scale sets, and that's a virtual machine concept. Now in my demo setup here, I'm deploying 2 Kubernetes nodes. So that's technically 2 virtual machine services inside the cluster that I can use for running my services. And try to move this a little bit out of the way. It's not allowing to move, but that's perfectly fine. But if you look at that little pop-up window, this is VM all zeros, and the next one is virtual machines all 0 number 7. So 2 virtual machines. So that means that Kubernetes by itself is already providing high availability, which means if one of those nodes would be down, then obviously the other one is still running. Now, the next step is running containers inside Kubernetes. What you need for that is a little script file. It's called a Kubernetes YAML file, or maybe you could use Helm or Chart, but it's a bit too complex for my demo environment. Because what I'm doing within my Kubernetes is running containers. But if I deploy my container in a standalone flavor, it means like I want to run one single instance of the container. It's not really going to help me in guaranteeing making it more high available. So what I can do in my Kubernetes YAML file is defining how many copies, like identical instances, I want to run. And that's with the replica setting. So what I define here is 3 replicas. And it's typically 3 replicas for 3 nodes. That would be the default setup when you deploy AKS without any specific modifications. Now, if we drill down on the containers, besides all the AKS internal system containers, you can see that I do have my AZ204 containers. And my cursor is again doing a little bit weird. So I'm going to highlight them for you. I got 1 instance, another instance, and this is my 3rd instance, where now I can see here that this is running on 2 container instances in 1 node, and the 3rd replica is running on a 2nd node, which again would mean if I shut down one of the nodes, that it would automatically keep my workload up and running. Let's see what my container instance is doing in meantime. $20.50, 229. Oh, it's painful without a mouse. 2050 229149. So if all goes fine, it's going to show me my e-commerce platform. Come on, you can do this. It's connecting to a SQL Azure, so that's also part of the fabric. where it's connecting to the database. I actually didn't check if it was actually running, but it should be fine. And providing me my workload, where the same idea comes in. There we go. So the same idea comes in if I'm connecting to my container instance, service would be down for whatever reason, something wrong with the container, something wrong with the instance, something wrong with the Azure region. You would need to come up with your high availability, deploying multiple instances, adding a load balancer in front of it. So with that, we're close at the end, where we have some time left for Q&A, perfectly on schedule. So a little recap already. I started talking about the different options you have in running or embracing public cloud. So talking about infrastructure as a service, mainly running virtual machines, storage, networking, moving to platform as a service, and eventually using serverless capabilities like logic apps or functions, or even microservices using containers. Then drill down on some high-level SLAs, what it means when somebody asks or talks about 3 nines, 4 nines, 5 nines ultimately, and then drilling down more in detail on the different Azure architectural building blocks, starting with the networking, 2 high availability load balancing options for 1 single region, load balancer and app gateway, and traffic manager and front door for the multi-region aspect. Then the high availability for virtual machine workloads, being availability sets and zones, application services, and containers, where you could run standalone container instance behind load balancer in the same region or multiple regions, or moving to Azure Kubernetes service. So again, you got my contact details here. Feel free to reach out if you got any other questions. I think this is a perfect time to check on the questions. So a little reach out to my moderator if there were any in the chat.
Thank you, Peter. Yeah, it's very interesting. I played a little with application gateway and something like this. It's very nice. Also, it's very powerful because high availability is very important. It's not only those things, of course, also full architecture, database, and so on, but it's very important to see these things. And also, if someone is interested in cost, could go on portal, Azure portal, and see costs and so on. So they can choose exactly what resource they can use to build an architecture, small, medium, or enterprise sites. So it's very powerful. I didn't see any question.
Okay.
So I think it's perfectly fine and clear. And so I thank you again.
Well, thank you for having me. I enjoyed delivering it and hopefully inspired some participants in the conference to learn about the Azure high availability capabilities, that it's not just all available as such, but you still need to think about it yourself.
Yeah.
Well, thank you.
Thank you, and
see you next time.
See you next time. Bye bye.
Have a good conference. Bye bye.
Bye bye.